let's get into the big topic of open source, something that we actually say at Red Hat.
This is so awesome.
We are an open culture that believes in the importance of
What is that process that a developer, or let's say,
as the Kubernetes ecosystem really boomed?
Ask an OpenShift Admin office hours live stream. I am Andrew Sullivan, joined as always by my co-host, Mr. Jonny Rickard. How are you today, sir?
I'm good, man. How are you?
I can't complain, despite the fact that my browser continues to just not be happy with my camera and whatever's going on here. So I'm pretty sure that the intro got cut off again, but stay lovey.
It's a little bit, yeah. But we're good.
I don't know what's going on with that. I blame society. I got nothing. I keep trying different things. Today I reset my browser before I joined, thinking, oh, maybe it's because of that, but I don't know. Anyways. Well, today is, not only is it November 1st, it is also the second very cold day that we've had here in Raleigh, North Carolina. Yes, I'm from the South, where 40 degrees Fahrenheit is cold. So yes. You can see that I'm like, I have a jacket on, I have a hoodie, which you can't see is I also have slippers on because, you know.
Can we see the slippers? I don't believe you.
No. That's just not. This is why I work from home. Yeah, this is why I work from home, is that I can, be comfortable. Even when I raise my desk up and I'm standing,
I really just want to see which pajama pants you have on. Like that's.
I don't have on pajama pants. I do not. I do have on athletic pants, but not pajama pants. So, because I was hoping to go for a run this morning, and that just did not. I walked my youngest out to the bus stop and decided, nope. It's windy, yeah. It's cold. This is, Andrew's a Southerner. Not going to happen today, at least not till
exactly.
So, today's topic is one that is near and dear to my heart. I think most folks who watch us regularly know that I'm a nerd at heart and love numbers and getting my fingers in things and touching storage and networking and all this other stuff. And etcd is one of those low-level components that just it pushes all of my buttons in all of the right ways. So I'm super happy to have William and Alan joining us on the live stream today. So gentlemen, I will let you introduce yourselves, and then we'll take back over for any top of mind topics. Jonny, I haven't even looked at the list because I've been running late. I don't know if we have anything. But...
Yeah, we got a couple, but we'll be able to move through them pretty quick.
Okay. William, please introduce yourself.
Sure. So William Caban, I'm one of the technical product managers in the OpenShift control plane, in charge of etcd for OpenShift.
Yeah, and I know you and we interact on a semi-regular basis as questions come up, and I have various things to ask about what's happening at low levels inside of OpenShift. So it's good to have you on the stream finally.
Thank you, and indeed, let's talk about all those corners.
All right. Yes, I'm looking forward to those. And for our audience, please don't hesitate to ask any questions. I know William and Alan both, and Alan, I'll let you introduce yourself in a moment. You are not unfamiliar with all of the questions that we get around, etcd seems to be the first sharp edge that people encounter when it comes to performance and stuff like that. So please, anybody who's watching, anybody who's listening, please submit those questions. We're happy to address those. Alan, please introduce yourself.
Yeah, so I'm Allen Ray. I'm one of the senior software engineers on the OpenShift control plane etcd team. And today is actually kind of auspicious. I haven't, told anybody. I don't even know if William knows, but today is my 2-year anniversary at Red Hat. So, they say it's 10,000 hours or 2 years that makes you an expert. So. Happy to be here.
Cool.
Yeah, congratulations. That works.
Yeah. Yes, there you go.
No, I've been having fun with those too. You got the lasers.
You guys are just showing off, and I don't like it.
Yeah.
Would you prefer the hearts, Jonny?
Are you on Linux too?
No, I have a Mac, but I haven't updated in like forever. And I think it might be a silicon thing, right? Where I need to have the ARM.
I think it does need the Apple Silicon as well as whatever the newest version of macOS is. So
Yeah.
got to
I'm
have
just
that
fancy.
AI chip on there.
Yeah, I'm just not fancy enough, I guess. So
Yeah. Well, welcome, William. Welcome, Alan. Greatly appreciate y'all joining us today. And for anybody in the audience, again, please go ahead and ask questions. I only request that you throw tomatoes, not rocks. When it comes to asking hard questions and stuff like that. That being said, as you know, Jonny and I love all of your questions. So please feel free to ask whatever it is that's on your mind. This is an office hours live stream, which means that whether or not your question is related to etcd, we are happy to do our best to answer it. And if we can't answer it, then we'll reach back in to wherever inside of Red Hat and OpenShift that we can in order to try and get that answer. As William can attest to, I reach out to him semi-regularly. Also, if you are not watching us live, if you're watching a recording, you can see Jonny and I have both started putting our email addresses in our name tags here. So you're more than welcome to reach out to us at any point in time. Send us an email, let us know what's on your mind or what you might be facing, what challenges you might be facing, and we'll do our best to answer those as well. So if you're listening to us and not watching us, which I know that there's some folks who do that, we talked about that a couple of weeks ago, tools that will pull down the YouTube video and extract the audio so you can listen to us like a podcast. It's very simple. Sully, Sully at redhat.com or Jonny, Jonny at redhat.com. We inadvertently follow the same pattern with our names there, Jonny.
that's right.
Anyways,
Like
hopefully it's easy. Yeah, hopefully it's easy for folks to remember. And again, it doesn't matter. I know this is episode 118. If you're listening to us 2 years from now when we're on episode 200 and something, by all means reach out. We get questions, we get emails from folks all the time. I got one the other day from episode 35, Jonny. That was before you were the co-host.
That's right.
I had to go back a ways on that one. So
yeah, that's like next paging, right?
Yeah. Like there was a time, a before Jonny time. What? I don't.
Let's not abbreviate that one though.
I was running through that in my head, and I avoided it. Yep, I was there with you. Anyways, so what are our top of mind topics today, Jonny? I don't even have the document open. I'm sorry.
Yep, no, it's all good. So we have a couple. OpenShift 4.14. Wow, that was hard to say. OpenShift 4.14 went GA yesterday, and there is a bulletin, an Access article that I'm going to paste the link here to, that just kind of goes over some of the the release information and stuff like that. So just feel free to check it out. And then we have
I'll tell you a secret, Jonny. So it's generally available. Anybody can go out. You can download the bits. You can install brand new 4.14 clusters today. They're fully supported. You can use the fast channel. You can upgrade today. It's fully supported. But you'll notice there hasn't been any marketing or anything like that. So the secret is they're waiting till next week with KubeCon to do all the announcements.
Oh, I pulled it right off of LinkedIn.
Yes. Oh, did you? Yeah. I think that's probably an individual. It might not have been one of the official accounts.
Okay.
The marketing team has said that they're waiting for KubeCon to do all the announcements. So keep an eye on cloud.redhat.com/blog, and you'll see a whole flurry of blog posts next week around 4.14, as well as all the other stuff that's going on. So if you haven't seen anything, that doesn't mean it's not GA. That doesn't mean it's not available. It's just the marketing team decouples releases from announcements.
So this was the official, unofficial announcement then.
Yeah. Don't tell marketing that we're talking about it.
Yeah. Whoops. Yeah. Like I said, I was on LinkedIn this morning. I saw it. I was like, oh, okay, cool. And so.
Yep.
Yeah,
and so next week we'll be offline for KubeCon, but in 2 weeks we'll be talking about 4.14.
Yeah.
So be sure to tune in 2 weeks' time, where we'll go through and do I won't call it a deep dive, but we'll do a deeper dive on some of the features there.
Yeah, and that's really the one thing I was going to lead into as well. It's our schedule coming up is it's getting tight. We're running out of we're coming up on the end of the year, and so obviously today is etcd. We've got KubeCon next week, so no streaming. Then we've got OpenShift 4.14, like you mentioned, and then we've got Thanksgiving break in the U.S., and then we've got ACM, and then our last two episodes we're probably going to do a recap on the year, and one other topic in between that we're not really sure yet. So running out of episodes for the year. If you have any ideas or any recommendations for episodes, feel free to let us know. And if it's something that we can tackle, then I think it's something that we'd definitely be interested in doing. But with 4.14, that hasn't been released yet. There are some API deprecations, and so I just posted those in here. Just go ahead and take a look. Like the one big one is the storage. It's going from V1 Beta 1 to V1. So just keep that in mind if you have anything that's using that. Like if you're doing a new install, it'll just be there. If you're doing an upgrade, it should just carry it over, but just be aware that that's happening. And then the other one is, the last one actually, is the call for proposals for Summit is happening soon. So
I think it's November 17th is the end date.
I think so, yeah. And then here's the link. So yeah, if you have anything that you want, if you have a proposal, if you want something talked about, or if you want something out there, right, go ahead and submit your call for proposal and or call for paper. I don't know what it is. I always say proposal, but go ahead and submit your entry and see if it gets picked up. Like Andrew sees those quite a bit, and so he's got a lot of
yeah. A couple
experience
of
with this.
couple of the people on my team are a part of the selection committee. I am not, because I'm focused on Red Hat One, which is the new name for Tech Exchange / Sales Kickoff. But I will say, so again, a little secret here. We have always heavily favored customer sessions for a Red Hat Summit. So if you are doing something that you think might be interesting to others, that others might want to learn about, if you just want to do a little self promotion, if you will, maybe build your brand a little bit, submit it. My approach has always been, and I tell this to the entire tech marketing team anytime I can, let someone else tell you no. Right?
Mm-hmm.
Because you never know what might be something really cool. Years ago when I worked for the government, when I never realized, I always thought, we work for the government, right? The government's always like 10 or 20 years behind, and all this other stuff. And then it turns out once I moved to the vendor side, we were actually doing some really cool stuff. We just completely, undersold ourselves.
Mm-hmm.
And so, I try and, make it a personal thing of like, don't undersell yourself. Let someone else tell you no. And even then, it doesn't mean you're not doing something cool. It just might not fit the theme or, whatever they're going for. So.
Yeah, and like it's like the old saying, right? Like the answer's no until you ask, right? Like it's always going to be no unless you put yourself out there.
Yeah.
So.
What's the cheesy? You miss 100% of the shots you don't take. There you go.
That's right.
Yeah, that's my motivational speech for today.
Good old Wayne Gretzky.
All right, let's talk about some etcd. So again, audience, thank you. First of all, rhope9, I see your chat in there. Yeah, sometimes they post the docs a little bit early. You can also go onto GitHubs. I don't know why I pluralized that. You can also go onto GitHub and look in the OpenShift project or OpenShift organization. There's a docs GitHub repo. So if you know a release, it's close to time for a release, you can always go and look at the PRs. Because usually they'll go in and like on release day or just before release day is when they go in and they merge all of those PRs. But you can always look early and see which ones are pending, and that's one way to see what might be happening in there. Again, little secrets. I feel like I'm telling lots of secrets today.
Spilling the beans.
I know. Keep me under control, Jonny.
This is too much fun. So
maybe I'm over caffeinated. Maybe that's the problem. Yeah.
No such thing.
Yeah. I'm not shaking yet, and so we went to the fair. Sorry, I'm tangenting. We went to the fair a couple of weeks ago. My youngest, who's 9, wanted to sample the ZipFizz stuff. I don't know if you've ever seen that stuff. If you have a whole drink of it, it's this little powder stuff. It's like vitamin B12. The label on it says that it is 104,000, like 100,000 plus % of your daily recommended value of vitamin B12. So my 9-year-old has a little sample of this and is promptly like vibrating in another dimension, and that was entertaining. Anyways, I'll stop tangenting now. etcd. So I want to kind of open our conversation here, and I want to ask two things, and then William and Alan, I don't know which of you will be best for which one. So one,
we'll tag team.
Okay, I want to ask, like, etcd itself is a critical component of not just OpenShift but Kubernetes. So I want just a high level, like, where does it fit in? Where do we use etcd? Kind of what purpose does it serve? And then two, why do we see so frequently like etcd performance issues? And I think, and Alan, I know you're smiling and nodding your head because in your head you're probably thinking, oh, Raft protocol and how it does all these things. So I'm hoping that we can get an idea of like why it's so critical and where it fits in, and two, why does it exhibit this behavior? And from there I think we can kind of dive into a bunch of different things. So sorry for asking hard questions up front.
No, this is great. And the reason I'm smiling and laughing is William and I had a little get together just to kind of, hash some ideas out of things we could talk about. And you guys landed squarely in the stuff we wanted to talk about. And stuff we were prepared to talk about. So, yeah, I mean, so etcd is the distributed key value store for Kubernetes. In general, a lot of the other stuff tries to stay stateless, but you have to put state somewhere. And so that is, one of those one of the reasons to have etcd and why it's so critical. And then, so that's kind of the high level of the first question. The second is etcd very much focuses on correctness. So because of the Raft algorithm, because we have a distributed key value store, we want to make sure that the stuff we are giving back to any request is correct. Now, correctness does not always, correctness and performance are not mutually exclusive, but that first one is the big ticket issue, and sometimes focusing on that can lead to some performance issues. So
yeah,
kind of the high level.
So I want to go back to the first question there, and William, I think this might be a question for you, which is, so you said etcd, like we use etcd to store things for state. So what type of things are we keeping inside of there?
In Kubernetes, we literally state everything. So every component in Kubernetes is fully stateless, except etcd is the only stateful thing in Kubernetes. So that means that anytime you do anything in Kubernetes and you want that to remain in existence even after a reboot, it needs to come from somewhere, and that somewhere is etcd. So that's one of the reasons why it is, yes, it's critical, but also is abused and overly abused by some of the configurations or by some of the patterns that are not necessarily aligned or clearly in favor of etcd. So if you try to put everything of every application state and type of object, you will start abusing etcd. And because of what Alan mentioned, etcd favors correctness over performance. So imagine now having blobs being pushed there on sometimes thousands of requests per second, sometimes hundreds of thousands. Imagine that, and now trying to have performance while keeping the correctness of all the replications. That's really where things start diverging between, do I want performance or do I want correctness?
Yeah, and so the only thing in OpenShift, Kubernetes as a whole, I think, that interacts with etcd is the API server.
Indeed.
And I think it's also important to point out that etcd is not a database. It's a key value store.
And more than that, it is a library. So etcd, well, it's etcd per se. Yeah, it has the Raft part, but it has something that is called the bbolt, which is the backend. And that is not a database. That is really a library for key store. So that means the functionalities that you normally have on a database, that for vacuum, inline processing of many things, do not exist. So over the years, what had happened is that etcd have gone and have to implement part of it, like defragmentation, like all this mechanism that you will normally have by default from an actual database, key value store database, let's say. So yes, that's That's a huge difference there. On etcd, you have the two components, the Raft part, which is just all this logic, which is extremely good. But then you have bbolt, which we can go deep into that. That's where most of the things that we see as suffering, that's the main cause of it.
So when I interact with the API server, so I submit YAML or I request, OC get pod, it is the API server is then turning to etcd and saying, hey, please give me all of the objects that match these criteria, right? So is it literally storing, and I honestly don't know the answer to this, is it literally storing YAML in etcd?
Let's talk a little bit for how it works in Kubernetes. So in Kubernetes, so you have the store part, right, in the actual disk. But then what you will see is that etcd has a full copy on memory. And what's happening at the same time is that the API server has another copy, a cache. So most of the time it will be answering from there and then just retrieving. But that's why you see that there's an explosion of memory utilization when you have a lot of transactions, because first you have the API server doing a huge cache of everything that's known on etcd. And then when you start writing or updating anything on etcd, what is happening is, again, remember, it's not a database. So how do we add? So we have to append to something.
Yeah.
And that append happen on memory, write to disk, and then you have to append. So all that's why the memory explosion happened. So that's how it works. It's really, basically, you have 3 copies most of the time at any given point.
And I don't know, Alan, I don't know if this is a question for you or not, but so I know there's at least one Kubernetes or pseudo Kubernetes, ultra small Kubernetes that uses SQLite instead of etcd. So which is a database. So is there a reason why we use something like etcd instead of a traditional RDBMS or even another key value store like Mongo? I think Mongo is a key value store.
That was my exact question that was queuing up. I had it going on. Good question, Andrew.
Yeah, I think it comes back to the correctness, the trying to make sure that you have the different voting members that will validate. There is no one source of truth. It is a democracy of truth, and you can the D in etcd, if anyone was curious, is distributed. It's literally the distributed etc directory. And so
that
at least I'm pretty sure that's right.
I mean, it makes sense. I like it.
It is now.
It is now. I've said that. I can go. I was a king for Halloween. I'll go and put my crown back on. But I lost my train of thought.
Distributed etcd directory.
Yes. So there actually. So yeah. I don't
SQL using the kind type
back.
of
I don't know how like Postgres and stuff do replication, but in general, we call it replication. There's a point of truth that is then replicated, but I don't believe that those replicators vote on what the main person or main instance is saying is the truth. And so there actually is one of the things that we kind of queued up to talk about. One of the upstream etcd community members has refactored etcd, and this is a work in progress PR that may or may not get accepted. Caveats. But has refactored the etcd to be the Raft part and the database part. We're including bbolt in the database part, and having an interface in between those two, such that theoretically you could put SQLite is what he put for this work in progress, but you could put another database behind there, and then you're no longer using bbolt. You don't have those intricacies or idiosyncrasies. I think that's how you say that word. But you still get the Raft aspect of it, the correctness aspect, the voting on what the truth is aspect. But then you could theoretically bring your own database that has some more of the nice to have features of a more well-established database than bbolt. Yeah.
And
go
to
ahead,
build a
William.
little bit on that, so in the market there are other key value store distributed. For example, CockroachDB is one of those. And I want to bring that because we have done experiment. Like, what if we replace HCD with CockroachDB or something like that? And it actually works. And it works well. I mean, the delta on latency, because they do have more latency than bbolt. Bbolt is kind of the fastest you can get on that. Now, they scale better than what we see on HCD, but then because of this Raft protocol, we really want that component because it's far stronger than the traditional, more generic databases. So yes, we have done the test with those, but personally, from my PM perspective, if we get, for example, the Raft component, which is extremely strong, and give the options to replace the backend, we might get way more scalable systems because we will benefit from the actual functionality on a database. Mm-hmm. Specifically, for example, on defragmentation, because a defragmentation process today implies you stop accepting any update. Mm-hmm. That's you're doing that. So when you have large system or a large database, actually, let's say a couple of gigs already, you're trying to defrag that. During that time, from API server, you can be trying to do something, but it cannot. So that initially on Kubernetes, that was working well. But nowadays, with the rapid evolutions and gigantic scale that we are reaching, that couple of seconds is too much. Yeah. So we need to improve that. And I believe that's one of the areas we can improve in HCD per se.
Yeah. Yeah. And just to kind of give a quick overview of why we run into that issue with defragmentation as it stands today, is we actually do it's not an in-place defragmentation. It is a full copy that is being defragmented, and then the old database is replaced with, the old database is replaced with the defragmented copy. And so as you're doing that, it goes back to that correctness. You don't have to worry about in-flight things. You stop everything, defragment, and you know that, we didn't accidentally squash a key or anything because, these keys are here. They're just in a different order. Yeah. And then we can replace. So it's very simple, but it is prioritizing that correctness rather than performance or latency.
And I have a whole bunch of things actually. So one, another secret for today, not something I regularly admit. I was a DBA many moons ago. And the way that you're describing, etcd and the locking reminds me of, row level locking versus page level versus table level locking in a traditional, RDBMS. So when we have to do certain operations, we're effectively locking the entire database. I also think it's important to point out that defragmentation of etcd is not the same thing as what you think about with defragmenting on a spinning hard drive, right? And that it's not necessarily optimizing the layout of data on disk, rather it's consolidating and removing white space.
Correct. It's the latter. It's because it's a a page file. It's an in-memory database. It is,
Yep. And I think William said it before. It's an append thing. It's never replacing something. When you do an update, it doesn't replace the entry. It's on number 4. It doesn't replace number 4. It appends it at number 12 and then just marks number 4 as being no longer needed. And the defrag goes in and actually removes number 4 and shuffles everything back up.
Actually, the defrag goes and read each one, write it, and it's literally doing one by one. Read and write into the new file. So that's what the defrag is doing. So it's not even too fancy.
Interesting. That's very cool.
It's the NASA approach. Be dead simple.
Yeah. Yeah. Well, I think that was one of the principles back when CoreOS first started doing all that stuff, right? Back when it was CoreOS the company, not CoreOS the now operating system that is underneath OpenShift. So I know there's a number of questions here. I have lots of things to say and ask about. I love to talk about the Raft protocol too and how it affects things, but we'll get to that.
Yep.
So Jonny, I know you're tracking questions.
Yep. So the first one came from rhope9. Thank you, rhope9. It seems that the requirements for the control planes have slowly been on the rise. Is it because of etcd, or are there other components to look out for? Also, have there been any discussions regarding including tests for things like vSphere problem detector operator to ensure things like etcd databases or data stores are used?
I think the answer to the first is a yes and a no. So etcd is because it's the lowest level infrastructure where it stores all the state. If you're pushing more state, if you're trying to do more things, if you're trying to make the cluster bigger or stretching it or anything to make yourself more scalable or anything, you're going to be putting more pressure on etcd. So it's not necessarily that etcd itself is getting slower or anything like that. It's that we're trying to do more and that's putting more pressure on that instance or that piece. I think,
I will add to that a little bit as well. So there's the etcd part, but remember that I mentioned that API server has a cache. Now there's another part that we are using more and more these days, and is the listening. Basically, we have an operator that registers to listen or to list huge amount of objects. Those cause a huge utilization of memory spike utilization on the API server. Okay, so a lot of this scalability in order to be able to support more comes from there. Now, the good news is that the API team and our team is working upstream, modifying the behavior such that instead of being a REST call for everything that need to build in the memory, it can be a streaming protocol, basically. And that's what you will see that is landing on the, I think it's the next 2 releases of Kubernetes. You will be seeing that really coming into play. And the benefit of that is that, for example, it goes from 80 gig utilization in some extreme cases to few megs or very low, less than 4 gig.
Yeah.
So
awesome.
it's a huge performance improvement. And for now, what you see is that the versions that we have to deal with the reality that more and more operators are registering or listening for every single object. Mm-hmm. And those trigger that huge memory utilization. So it's a combination. It's not one thing.
Yeah. Yeah. And I want to call out a couple of things there. So when you say operators are listening for objects, what that means is, if I deploy, I'm going to call it the OpenShift virtualization operator, because that's the one I was fiddling with this morning. It sets up watchers, or listeners inside of the API server that says, hey, tell me anytime this happens, right? An object with this type is created or modified or anything like that. And each one of those, of course, consumes resources as it's having to, the API server is having to do those notifications and all that other stuff. So that's what you're referring to when you're saying that that's as the cluster grows, as more things are happening in the cluster, it's more resources, even if it's not doing anything directly, that are being consumed and used by the API server.
Yes, that's the first part. And the second part is the one that, for example, let's say that you have a security tool that is monitoring every single pod manifest for or something like that.
I know one of those. I think we
yeah.
have.
So those those are listing all those resources on a regular basis. So the same with any other tool that is doing any type of scanning or monitoring on the system, they can be listing, and those listing literally consume a lot of memory today.
Yeah. And I know I'm skipping over a couple of questions here. rhope9 asked, would etcd performance be more memory bound or CPU bound, and will that be part of the drastic pending improvements? And also, I want to touch on etcd performance, so I want to use this as a launching point once you answer the question.
You want to take that, Alan, or?
Yeah, I'm trying to decide which one it would be.
I mean, my personal opinion is neither, because before you encounter CPU or memory issues, it's going to be probably disk, maybe network. And
yeah, I'd say disk. Disk is going to be the big one, and specifically latency. Getting higher IOPS is the important thing there. In etcd, so because the bbolt is in memory, there's in OpenShift there's a hard limit at 8 gigs. So really, you're not going to be using in the happy case. There are times when bad things happen and the memory graph looks not like a sawtooth. Sawtooth is happy. But in general, yeah, you're going to hit disk before you hit CPU or memory.
And that's typical in logs too, right? Like when you look at it, you can see like the pressure on disk and stuff like that, where it starts to spike and stuff. So
yeah, and I want to. So why? I guess I want to clarify, why is disk so important here? And I think for me it goes back to Raft, right? Because we want to safely store information.
Yeah.
So when the API server says, "Hey, etcd, store this piece of information for me," the leader receives that information. And I don't know if it does a disk write at that point to basically store it or not. But before it commits it, it goes out to all of the members and says, "Hey, we have this new piece of information. Please confirm that you've got it." And so they all receive it, and then they store it in a temporary location. And then they all come back and say, "Okay, I've got the information." And when a quorum of them have come back to the leader and said, "Okay, I've got the information," the leader commits it and tells the others to commit it. So you notice there's like 4 network operations and at least 2 or 3 different storage operations that all happen there. So that's why etcd is so network and storage sensitive, because any little bit of latency that happens there means that one operation, hey, etcd, store this thing, update this thing, every one of them gets stretched out in that respect.
Yep, perfect. Couldn't have said it better.
I've done this description once or twice.
but it's good to see that back and forth, right? Like, because I do think that you just explained that really well. I mean, because then you're actually seeing that communication and that transaction happen. I think that's really well explained.
Yeah, and if anyone actually wants a visualization, the Raft GitHub IO page has a neat visualization that you can kind of play with and see how the consensus algorithm works a little bit better. I just posted that to the hosts
on it.
Yeah, thank you. So circling back to some questions here. Let's see. I lost track of questions.
Yeah, another one was
Mannequin.
yeah, exactly. You want to take it?
Yeah. So I always wondered why /etc and the etcd volume don't exist on their own separate mount points, like a separate partition or drive or device. I don't know if that's so much related to etcd itself, or maybe like the CoreOS or the installer team, why we've chosen to do it that way by default. I do know that with hosted control planes, each one of those etcd instances gets its own PVC.
Yes, and I mean, there are procedures for you to move the etcd volume to a dedicated volume. Okay, there are. The etc, if you notice, sorry, my dog.
Mine was making noise a minute ago too. If you saw me turn around and I snapped my fingers to get her to stop.
No, she wants to play now, So what happened is that etcd runs as a static pod. And most of the information, or actually all the information on the static pods, you'll see that in our case live in /etc/Kubernetes/static pod something there. So that's that has been the evolution of it. Okay, but yes, you can. There are KCS where you can move this to its own dedicated partition, and in some cases, we will recommend that even when we don't have like an API mechanism to do that nowadays. So it's more like a manual procedure.
Yeah.
But on areas, for example, where you have very slow disk, and it happens that you were able to put like an NVMe just for this. Okay, so yeah, sure. So that's the answer to that. So it's more historical and how it comes from the static pods first, and yeah, and you can move it if you need it to.
Yeah, and in the static pods, those are the ones that their configuration is managed via machine config. And because they're pushed as effectively unit files, I think, and managed through systemd at the CoreOS level?
No. So a static pod, so in Kubernetes, basically you can run pods without having a control plane. And how that is achieved is you have the runc, and basically you have the kubelet, right? And the kubelet configuration, you can set up a path that you can have the actual YAML in that path. And when kubelet start, it will just read that and send that to runc and execute those pods right away.
Okay, so that's really interesting. I've been misunderstanding, it's static pods for how long have I been doing this now? Like 5 years. I always assumed that static pods were the ones that we referred to as being started and managed, via systemd units for cryo, or cryo to execute. But they're actually pods they're still started and managed by kubelet. They're just read from a local file system. I don't have to rely on the control plane to schedule anything or anything like that.
Exactly.
Yeah, and each node gets one. It's actually, if you ever run a STIG on OpenShift 4, that's one of the findings is that you have static pods in a local directory instead of it being controlled by the API server. So it's a security finding that they do that, but it's one that like we POAM because it's like, well, we do it for a reason. So
yeah, that's a static pods. Yeah, are not controlled per se by the rest of Kubernetes, but you don't want to abuse them. Now, what we are using them for is what usually will go into a systemd service, for example, and you want to run that as a pod because it needs to be up before the control plane is up. So that's when we're using. So that's definitely for. So that's where you want to use static pods, but be careful with them at the same time. Yeah, there's a lot of very cool experiments. If you have, for example, very extreme edge devices and you still want to reuse those before Podman Pod days, that was a pretty cool way. Now with Podman Pod, that solves that problem.
Imagine remote worker nodes could also take advantage of that.
Yes.
Let's see, other questions that we have here. etcd security. Refactoring for local PKI to use an external, or from local PKI to use an external or corporate provider instead.
Okay. There are two sides on the encryptions for etcd. There's the peer-to-peer part, and you have certificates there that are handled by the actual etcd. Okay. But everything else is on the API server side, which is confusing, but that's how it works. So the encryption, the actual encryption of the etcd objects is really on the API server, not on etcd. So with that, so that's where it starts. So, and yes, for example, in our product, in OpenShift, we do have the two encryption mechanism. I mean, the two encryption modes, I should say. And to the specific question on bringing your own, yes, that's something that we are working right now. I cannot say 100% promise but this is something we're targeting for 2024, such that organizations can bring their own KMS for encrypting each city. So if all the gods of the beach align, then we'll have that next year in our product.
Those things never change. You know, it never slips. Never.
Yeah, exactly.
Yeah.
That's why I'm saying next year.
Yeah.
Yeah.
Let's see.
Sometime soon, TM.
Yeah. Maybe, probably.
Maybe.
Yeah. Art Lover, I'm studying for my RHCSA certification. Can you tell me if I need to go deeper in Linux if I want to get a good job in cybersecurity? Jonny, you're probably more familiar with these types of things than I am. Cybersecurity is such a broad,
Exactly.
non-specific thing. Like I would say, clearly I'm biased, right? I work for Red Hat. You can never go wrong learning more about Linux, but cybersecurity is broad, right? There's the networking aspect, where you want to learn more about, probably Cisco or Juniper or, F5 or Citrix or all of these other things. There's application security, where you're going to want to learn more about like programming languages and stuff like that. There's, infrastructure security, and like, there's just all kinds of different ways that you can interpret that. So I think, broadly speaking, yes, it's always going to be better to have, additional knowledge around how Linux works or how Windows works and stuff like that. Linux underpins just a tremendous number of things.
Yeah.
Even things that aren't obviously Linux are still Linux.
And growing, right? I mean, like Linux is just kind of taking over the world lately. So this is the year 2024, the year of the Linux desktop. It's going to be the year.
Yeah.
It already is the year. I'm on Linux desktop.
There you go.
That's right. I mean, yeah, that's true. I'm on Fedora laptop.
On that question of the cybersecurity, this is some advice. So identify what you want to do with the cybersecurity, because as Andrew mentioned, it can be many, and then go into that topic as low level as possible, because that's where you will be really spending your time, and that's how you can become really effective on that area of the cybersecurity. And Linux in general, identify if it's on the network side, go to the network stack. If it's on the libraries, go into the libraries. You have the code. It's beautiful because of that. And go deep into those. Many moons ago, I used to love cybersecurity. Now I try to hide from it. So yes.
I feel the same way about Java.
Yeah. I'm not touching that. I'm staying away from that one. Did we catch up on questions, Jonny? I think we did.
Yeah, I think so too.
Okay.
Yep, I think we're good to go.
Okay. And now I forgot the questions that I had because I got distracted.
So I do have one question about like with the upgrade that you're talking about, where the API performance improvement and stuff like that. On the etcd side, so right now ConfigMaps have like a size ceiling, right? I think it's like a megabyte or 8 megabyte ceiling for like the size. Now, when you do this upgrade, or you're talking about this upgrade to the way that etcd performs, will that change on that side, or will the restrictions that currently exist for example, this ConfigMap, right? It'll just stay the same, or will it grow by 10 or whatever?
I don't think we know about that yet.
Okay. Okay.
Is that there are pros and cons to that, because people already abuse etcd.
Oh yeah.
So we don't want to give more reason to get even more views. Okay, etcd is meant to be like state, not to be your database. That replacement. Okay, so that's the part of that. But I think that all those are things we have to explore once we identify a good path forward on that front. Okay.
Awesome. It's a good answer.
I remember my question now. So etcd I'm going to say wrongly, gets blamed for a lot of performance issues, right? Because etcd is just doing what it does. Really, oftentimes it's the underlying storage and network that result in that. So, William, you pointed out to me in a Slack conversation that we had a few weeks ago that 4.14 introduces a tech preview abstractor to the operator for modifying the timers associated with etcd.
Yep.
So I have two questions that I want to ask. So one is, what are those timers? Yes, thank you, macOS. What are those timers? And kind of what does each one of them mean? And two, what, like, when we say this is for slower hardware, right? We're increasing timeouts and stuff like that. Is that actually helping performance, or like, what are we actually doing there by modifying those things?
So that guy.
Yeah, that's I implemented that. So I'll answer the last question
Okay.
about performance with a cheeky response of, if the cluster is not able to handle requests because you're having a lot of leader elections, you're going to have a lot of performance issues because you can't handle requests. So yeah, it's not, you might increase latency in some places, but being able to actually do work is better than not being able to do work.
Yeah. And just pause for a second.
Yeah.
Leader election. Why are leader elections bad?
Okay. Because we'll take a step back and I'll answer that question, because that is one of the timers that is in this change. So the heartbeat timeout and the leader election, or the heartbeat interval, and the leader election timeout are the two timers that are controlled by these this toggle, the profile. So the heartbeat interval is the how often the different instances talk to each other, just to say, I'm here, I'm still alive. The leader election timeout is how long each instance should wait before it says, I haven't heard from the leader, it's time to do an election. Because it is the peers that, force elections. It doesn't happen on any periodic thing like in real life. So those timers, if you're having network latency, disk latency, by default, the heartbeat interval is 100 milliseconds and the leader election timeout is 1 second. So by default, if you're, at 150 milliseconds for your heartbeat, you're pretty close. And so it would be really nice if you had a little lever that you could just increase that. But we want to be practical and not give all of the levers, because then we can't test every single combination. We have two combinations, and that makes our lives a lot easier. Yeah. So the default, 100 milliseconds heartbeat, 1 second leader election timeout. The slower category, which you should not feel bad for using. If you need to use it, that's fine. We don't judge. Is 500 milliseconds heartbeat and 2.5 seconds leader election timeout. And it is sacrificing a little bit of latency for being able to actually do things. Because when a leader election happens, and I've come back full circle now, when a leader election happens, you can't accept things. It's like defragmentation. You have to stop the world, figure out the leader election, and then once the leader has been elected, then you can continue moving forward. So if you're having a lot of leader elections, you're not going to be able to get any work done, which is why my answer was cheeky before.
Okay. So I'm going to try and describe this, and you tell me if this makes sense. So etcd is doing its thing, right? API server says, hey, store this data for me. And for whatever, it sends out that information and it crosses, network, storage, all that other stuff. So one of those nodes stops responding. And by stops responding, I mean, it doesn't necessarily stop responding. It just takes longer to respond. It could be because of CPU pressure. It could be because there was a network latency spike. It could be because there was a disk latency spike, any number of things. So etcd will throw out an error basically saying, hey, it took too long for this node to hear back. So by setting the tunable to slow, you're not fixing anything. You're basically just setting it so that it doesn't throw that error as often. With the secondary effect of it also extends the amount of time before it will trigger a leader election. And as we said before, like when I go, hey, when API server says, hey, etcd, store this for me, the leader is the one that receives it. So without a leader, it can't basically coordinate. It can't accept, store, retrieve all of that data inside of there. So if your cluster, hey, I've got a cluster deployed, it's running on storage, it's marginally able to keep up with my workload. My workload is X. When I go to X plus 4, I start getting leader elections, things start falling over. By setting the tunables, you might get to X plus 4, but X plus 5, you might see it come right back. And either way, it's not going to decrease the latency of those operations. It's just going to prevent potentially those leader elections from happening and it stuttering along.
Yeah.
I will add to that. So basically, you can achieve stability on non-ideal conditions with the caveat that also means it might take longer to detect actual failures event. So nothing is free here.
Yeah, that's fair. That's fair. Yeah.
And that's why we wanted to package it into, you get, the fast, you get the default lever, you get the slower lever. And there may be more levers, more profiles, more levels, not levers. As we continue this, we might even have a faster one if we want, if we need a one in between, we're going to see how it's used and see, listen to feedback. But yeah, that's why we wanted those discrete steps, because the more variables we throw in, the harder it will be to figure out what a problem is.
Yeah.
But right now, if somebody's on default and we look at the logs and we go, oh, they're timing out by a couple, 100 milliseconds or 150 milliseconds, put this on slower. You'll be able to actually do work, just with this caveat that William just said.
Yeah, and I see there's a number of good questions that are coming in. So I want to touch on Peter's question here so something like GitOps puts a huge load on etcd, which is indirect, right? It's a bunch of API calls because GitOps is constantly verifying and rectifying. And Jonny, I'm going to rely on you. You're my GitOps expert. What's happening behind the scenes. So using Argo, using GitOps, kind of automatically puts additional load on the API server.
Remember the list I was mentioning before?
Yeah,
that's one of the cases. So something like Argo, every 3 minutes by default, it will list every single object that it should be monitoring. So imagine having many instances of this, doing this, and how many copies you will end up having in memory in order to process this. So that's a very good example on why we need to fix that on the API server, such that those do not have the same impact that we're seeing today.
And
that's awesome.
Keeping in mind what you said a moment ago, I don't remember if it was Alan or William, of there's trade-offs here, right? If we increase that failure timeout, it means that it takes longer for us to detect actual issues happening. So the second half of Peter's statement here, or really the question part, is what's the best way to tune it? And I think what you said there, William, is, by default, it's every 3 minutes. Well, if we push that out to 5 minutes or 10 minutes, the trade-off there is, yes, it's going to consume less API and etcd resources, but it's going to take longer for it to push out changes. When you update that Git repository, right? And again, I'm Jonny. I'm kind of relying on you here. Does that make sense?
Yeah, you can set it up where it'll auto heal. So basically, it goes out and it's literally tracking like the difference between cluster and state, right? And where with the reconciler, that's going out, the operator's doing its loop every 3 minutes, and you can update the timer on that, whatever. But yeah, if you have it on auto heal, it's always checking to make sure. But if you updated your timer, guys, you'd basically go from like, all right, go get a cup of coffee, come back, and then it should be synced. Or you can go and refresh it, right? If you know that you've done something, you can go in and automatically check it. So
Yeah, today those are the ways we have. It's really playing with that timer because we don't have any alternative to that. With all this part of the streaming API that is being added to the API server, those lists should not have an impact anymore, and we should have extremely improvement on performance for something like if you want to run GitOps on very even smaller interval. But we have to wait and see how it really comes out the other side within the next 2 Kubernetes releases.
yeah, I was saying it was awesome a second ago because like we were talking about a long time ago, GitOps and the performance impact that it has on clusters and stuff like that. And not just GitOps, but like Argo CD and Flux, whatever it is, whatever the tool is, right? And I never knew that like it was making that list call every single time. So like that makes a ton of sense on why like okay, when you have multiple instances of Argo on a cluster, that's why it can bring it to its knees sometimes. So
well, think about ourselves. How do we check something? We all kubectl get all the pods, those are lists.
Yeah.
So imagine a tool that need to do that very often in order to make a decision. So yeah, those are the lists.
Yeah, that's a ton of sense now.
Yeah, and our Hope 9, so I'm going to summarize your couple of statements here and in order to point out something or ask something, which is, like you're mentioning TCP sync or SYN, sign, a bunch of other things in here. Do we have anywhere, I know the default performance dashboards have a number of etcd counters. Is there a blog post or a KCS article or something like that that has sort of a breakdown of maybe some relevant or important things to look at for etcd monitoring and etcd health?
The blog post that was shared before on about etcd, it does have some of the information.
Okay.
On the new OpenShift, what you will see is that there are some enhancements to the etcd dashboard per se, because we are trying to make visible, really clear and visible, the metrics that are important. And one of the metrics that we are trying to make very, really visible is, for example, the latency, but the jitter effect on latency for both the network and the storage, because the storage also has jitter. And we usually forget about that. And we have found, for example, cases that in cloud providers, you can have an SSD back storage, but the latency is great most of the time. From time to time, we see these ginormous spikes on the latency, and those are the jitter, and those can trigger and have triggered re-election on etcd. So we are making those really visible because you have to really consider all of those. And I think we also have a KCS article that we wrote with far more details on this. I could probably, I don't have it right now, but I could probably find the link to it.
I don't want to call out any one hyperscaler, but like we have a specific exception in the installer that puts different leader election timeouts and stuff in for that particular hyperscaler because of all of that jitter that happens. So
yes, yes.
Thank you. It's helpful, and I appreciate the link to the blog post. And thank you for sharing it again, Jonny. I know a lot of us, as administrators, etcd is one of those, it's core to, it's fundamental, it is critical to every aspect of the cluster functioning. So when it experiences pain, it ripples across the entire cluster. So we all like to know what's going on and like what's important or what's not important and stuff like that. So thank you for including that.
Sure.
Yeah.
And one more thing before we close, because I want to make sure. So there's something that you try in one of your episodes on using etcd to recover a cluster, okay? And you had the painful experience that, it's not exactly a good way of recovering a cluster. So something that is dev preview on 4.14, but we have a backup API on etcd now. on the etcd API. And the way it works is that it literally is part of the API now. So you can even use GitOps to set up these parameters that it will do the backups automatically for you. And it does it in a way that it's making sure that it's consistent and it's good. And that API will continue to evolve such that you can do automatic, for example, recovery of 1 or 2 node failures for hopefully 15 or 16. And from there, the end goal is for you to be able to recover from a control plane failure. That's our end goal. So we are not ignoring that. We are actually working on it. There's a ton of logistics that we have to change in the operators, but we're working on those. And I wanted to just make sure that everyone is aware that, yes, we are working on it right now.
Yeah, I'll point out that we haven't even really touched at all on the etcd operator and what it does versus etcd itself. Because etcd operator is a whole nother level of magic around like making it work inside of OpenShift and tolerating and fixing changes and stuff like that. So yeah, there's lots of cool stuff happening there. Alan, I don't know if you had anything to add there.
Oh, I was gonna have a glib response. It operates etcd. It's it's all you need to know.
Yeah, well, so to your point, William, one, I think I would assume control plane machine sets play a role there of, hey, I've lost a control plane node. The control plane machine set operator in conjunction with the etcd operator work together to basically replace that node.
It's funny that you mentioned, because part of the enhancement that has already happened in the etcd operator is that it detects when, for example, there's a rescaling on a machine set that for the control plane, and it does the recovery and scaling properly for etcd. So that's what we are working to also bring for, let's say, UPI and other methods that do not use the machine set control plane as the initial phase for that failure of 1 or 2 with automatic recovery. And then after that is the full recovery thing. Very
cool. Yeah, I'm trying to wrap my head around, replacing 2 or even the entire control plane and how that works. And my mind is boggled. Yeah. So
anxiety is starting to kick up a little bit.
Yeah. Let's see. There was another one up here. Manakatan. What if all etcd members are leaders and followers? Why does it have to be an odd number of members? And how much does Quorum impact etcd? So I don't know if you want to break those apart.
Yeah. So what if all members? I'm gonna take the second one because I haven't quite parsed the first one yet. So yeah, as our Hope kind of mentioned, the odd number is just to avoid stalemates. If you have 3 people, you always have a majority. If you have for a binary question, if you have is this correct? If you can only answer yes or no with 3 people or 3 replicas, you're always going to have a majority, either yes or no. Same thing with 5.
And it has to be odd but not prime.
Correct.
Okay.
Yeah, you get into funny things with the bootstrap node of etcd of being a quorum of 1, but that's for a short time while things are coming up.
We just pretend like it doesn't. Yeah, it's okay.
Yeah, it's fine. But how much does the quorum impact etcd? That's a kind of interesting question because the etcd is the quorum. So it would be, the difference of using something like, a replicated database where quorum, where the correctness is not voted on, it is a single point of truth, versus the whole point of using etcd is you have that ideally you have that requirement of correctness.
So what I'm wondering is, does that question stem from the concept of, and I think Ceph does this, but I know there's other things where there's a quorum, quote unquote, watcher. So there's 2, what I'll call data nodes that participate, and then a third non-data node that's just a quorum watcher. So that it's that tiebreaker when it needs to make a decision. So in that case, with that Quorum node, non-participating but observing, Quorum node affect performance. But that's not the way it works.
Not how etcd works. Yeah. There is the concept of learners in etcd, but they by definition are non-voting members. So, and there's a kind of neat thing that we could talk about if you want to get into the weeds for some experimental theoretical stuff.
Yes.
Is it okay? We're going.
If y'all are good with it, I'm sorry. I'm like, I could listen to you guys all day on this. Like, this is an awesome topic.
So one of the things, and I will post this. Yeah. Oh, I think we've already posted this one, but if we haven't, we'll go ahead and post it. In Williams' A Guide to etcd, we talk about, and actually, I'm going to go ahead and share a portion of my screen for this, because there is a graphic that I want to talk about. Let's see if that's good. So this graphic right here. So one of the things that we notice is that, we have in OpenShift, we do 3 instances. And part of the reason we do 3 instances is that we have the single node failure redundancy. And it's a good sweet spot of redundancy versus write performance. Because the more nodes, the more voting members you have, the longer it takes to get a majority and vote on something. Part of the reason why we don't currently support 5 nodes, because the write performance would be abysmal. So one thing that I think would be really neat, and this is a hypothetical, this is not planned currently, but taking the concept of a learner, which is a new member that catches up but is not voting. So it has no impact on read or write performance. It is just sitting there listening for the current state. And it helps, it can help with onboarding a new member to make them a voting member. One of the things I think would be really, really neat is having, like you would have a hot spare hard drive in a data center, JBOD, a hot spare etcd instance. So you could take that concept of a learner and have them ready to be a voting member should you have a node failure. And that way you get some of the benefit of a 5-node cluster without having the write performance issues of a 5-node cluster. You'd still be a 3-node cluster, but it would be, a 3+1 or 3+2 or something like that, where those hot spares are just sitting there receiving all the data, but they're not voting. They're not telling anybody that, yes, I received it.
It's not having to wait for confirmation from them before committing.
Exactly.
And I want to point out that, why is this important, right? Why is it important, one, to have a hot spare, and 2, for it not to participate, right? So not participating or not voting means that, like I said, it doesn't have to wait for that ACK, for that confirmation before committing the data. But 2, in a recovery scenario, so I lost one of my 3, voting members in the cluster. So the recovery operation can kind of go 2 ways. So one is we take a relatively recent backup and we restore it. And then the 2 surviving nodes sync whatever data has changed since that backup was taken. And then it's now caught up, quote unquote, and rejoins as a full voting member.
Right.
The other option is for those other 2 members to just replicate the entire database. So in both of those instances, it's either a little bit or a lot of data probably that's getting synced, but it's adding additional resource requirements, additional particularly reads that all have to be read from those nodes and written to the new node, which taxes those etcd members. It taxes the underlying infrastructure. Think a lot of times in virtualization where we put all of our nodes into a single data store. Now my underlying storage is getting that much more resources, so it can have this, again, ripple effect of what's happening. So
yeah,
minimizing the impact of restores is important.
Well, and to kind of further drive home that point is you're adding more what was the word you just used? You're putting more pressure on a system that is teetering on the edge of Quorum, where you really want to recover as quickly as you possibly can to restore Quorum. And so that would be the other reason of having something like a hot spare of you can, as soon as we detect that node X is down, spare node Y is already up to date. It basically says, I would like to join as a voting member. And maybe, in this theoretical design, the leader could say, oh, I know about this node. You are now a voting member. The details are fuzzy because this is an idea.
Yeah. So, and I think, so that first question, what if all etcd members are both leaders and followers? So I think the question there is, why do I need a single leader, right? What if my API server could just send a request, here, please store this for me to any of the participating members in the cluster and have it send it out to its peers so that there's more or less 3 entry points into the cluster, into etcd.
Yeah, and that's the cheeky response is, does the United States have 2 presidents? You can't have
distributed consistency is hard.
Yes. And so, ultimately there has to be, when you're storing something, there has to be a sequential aspect somewhere. You have to put things in order at some point. And when you're putting things in order, you can't be threaded, you can't be distributed, you can't be parallel. You have to be able to put things in a correct order. So having a single point of entry verify or makes certain that you have that correctness of not only the data but also if the data order is important, you have that requirement that the validation that that is the correct order.
Distributed, I look back at RDBMS, traditional RDBMS, relational database, has this distributed consistency problem as well. Particularly in a table where everything needs to be ordered, right? There's a primary key for each one. Well, if I send 2 writes to 2 different members at the exact same time, are they both going to pull the next number in the primary key column?
Yep.
And if they do, how do you deconflict that? And so I see Stephen Reeves posted in here about Paxos can have multiple leaders, but it makes it incredibly complex. Yeah, exactly. Because you have to deconflict that before you can acknowledge back to either one of those requested write clients saying, okay, I stored your data and here's your primary key for accessing it.
Yeah.
Same exact principle here. I'm scrolling back through comments and questions here.
And the last comment, yes. So basically the followers behave as all the possible VPs to get in line. So
let's see. I lost my beat here on keeping up with questions and stuff.
The last question that we have is from Steve Cassidy.
Can you explain a little, if you have 3 control plane members and lose 1, then everything continues, but etcd goes read only. Lose another and you're really, really broken.
Yeah. That's why recovering Quorum is so important.
Yeah. So with 3 control plane members, basically 3 full etcd members, it's functioning normal. It has enough members where it can authoritatively, consistently, and constantly determine quorum. Enough members have acknowledged this. We're good. We can safely store this. If you lose 1, etcd continues to function, right? The 2 surviving members can both say, yep, we've got this. We can store it. And read and write operations continue as normal. If you lose a second, now I only have 1 member. I don't have quorum, so it can't talk to anybody else and say, hey, we got this, right? We can safely store this, type of thing. And so it goes read-only.
Yeah.
And at that point is where bad things start happening, right? And within OpenShift, within Kubernetes, after 5 minutes, the worker nodes start to evict workload and all this other stuff. So you have a brief window for recovering that.
Yeah. And that also happened because at any given point, an etcd member will know how many members should there be. So that also allows, for example, in the case of a complete partition where each member remains alone, each one of them will see one, not at least enough for have a quorum. So we protect the database, the information that way. So that's one of the, again, more the accuracy, or I forgot the word that Alan used at the beginning, but that correctness is what we're trying to protect.
Yeah. Yeah, it's, I used to work for a storage vendor, right? Losing data is a cardinal sin. And, similarly, when etcd, right, which is your source of truth, if you can't trust that it's accurate, that's bad. I did find the other question that I was looking for. Hakan pointed out, so with hosted control planes, the control plane is moved to the same, basically its workload in a different cluster. Does that mean it can access Cert Manager running in that hosting cluster to use that for its certificates, as opposed to the mechanism that's in place now?
Stay tuned. Stay tuned. But a longer answer to that is, yes, you will see that there are more advances on certain things, like, for example, the ability to use KMS, external KMS already is available on HCP. It's not available on the regular OpenShift. So we are converging that. And as part of that, we're also figuring out the way to bring Cert Manager as a more core element, I will just say that, to OpenShift, such that it has more pluggability on the certificates areas of OpenShift that customers have been asking for.
Oh, I get it now. Because HTTP uses STS, right? Because it's using the short-lived tokens to go out and talk to the API from the cloud to be able to like get the secret or whatever generated and push it around, right? Is that what you're talking about, or are you talking about something like completely different?
Sorry, I didn't hear the first part of the question.
Okay. Yeah, I was saying like in hosted control planes, like they use STS and AWS is STS, right? That short token service. Is that why you're talking about like that's because HCP is trying to use that, right? They're trying to use those short-lived tokens to maintain that, least privilege, right? Where
I don't know.
Okay, no, that's fair. That's completely fair.
I don't know.
That's completely fair. Thank you.
I think we caught up on questions here. So acknowledging time and all that other stuff, William, Alan, I don't know where in the world you are. It looks like it's still daylight for you, Alan. I can't tell with you, William.
Eastern.
Okay, so acknowledging time, and we all have things to do. We'll take just a few more minutes. So for our audience, please don't hesitate to post any questions that you have into chat. We'll do our best to answer those here. If you have any questions that come up after the stream, and etcd is, again, it's one of those things that we all always have questions. I could, as Jonny said before, I could keep you all busy for hours. So if anything comes up after the stream, if you're not listening to us live, feel free to reach out to either Jonny or myself, jonny@redhat.com or sully@redhat.com. We're happy to take those questions, do our best to answer them, and when needed, bring in William or Alan or any of the other experts to help with those. So with that, I think I'm going to ask a very generic, which might make it a hard question to answer for both of you, which is there common issues, common problems, like things that you think that we should watch out for or be prepared for as a cluster administrator? I know my personal answer will probably always be storage latency. And extrapolating that out, we've talked about this on the stream before and I sort of alluded to it earlier of, hey, if I've got a single, vSphere data store that I'm dumping all of my nodes into, and I've got 2 or 3 or 5 or 10 different OpenShift clusters, which is, 6 or 8 or I don't know. I can't do math, never do arithmetic in public. Like I'm dumping all of those IOPS, all of those latency requirements into what is probably a single LUN coming from the backend data store, or the backend storage device. So just be cognizant of those things, not just as an OpenShift admin, but when you work with your infrastructure provider team and whoever that happens to be and stuff. So I don't know if you all have any thoughts or suggestions in that regard.
Don't use these. I brought props. And by brought props, I mean these have been sitting on my desk for a while. For the listening only viewers, I'm holding up a spinning disk hard drive.
Yeah. Yep, I know in the rather active and thriving Red Hat Home Lab community, it's been a couple of years now, but when OpenShift 4 first came out, there was a lot of conversations around like, hey, my home lab is using, either RAID arrays of spinning media or even flash accelerated spinning media, and I keep hitting issues. And there's only, for better or for worse, some sort of flash media, all flash media, whether it's SSD using say SCSI or NVMe or is generally the recommendation.
Yeah, and having the kind of to tie back in some of the things that we've talked about today, having the different profiles where you can add a little bit more tolerance to stuff that might slower hardware. Is one of the things that you can do to make things better. Like William said, keeping an eye on the jitter, keeping an eye on the memory usage. Memory usage should look like a sawtooth. If it's not a sawtooth, then there might be problems. If you see a linear, that's time to
random tangent. Why is it a sawtooth?
The garbage collector.
Interesting. Okay. I mean, I knew that was expected. I just didn't know it was actually. So garbage collector is presumably going in and purging from memory all of those stale entries.
Yeah. Well, so that's where we get into compaction and defragmentation, because defragmentation is not the only. There are two different things of reclaiming etcd storage space. We've talked about defragmentation, but we didn't talk any about compaction. But they work in tandem. But yeah, you're reclaiming space, whether it be through defragmentation and compaction or through the garbage collector, going through and, with all of these, with all of these requests, you are serializing, you're deserializing, you're creating memory as you're, reading stuff from disk. Once you're done reading something from disk, that's garbage. And since Go is a garbage collected language, which is why I get really excited personally, because I'm a big old nerd, when I read Go blogs and I see that they've increased the tail end of the garbage collector by 40, they've added 40% performance to the garbage collector. I get really happy.
And indirectly,
we got it.
Oh yeah,
I'm sorry, I couldn't resist. I was trying.
Yeah, so something real quick I want to again highlight on this is, so when you see a problem with etcd, it's not necessarily because etcd is the problem. Okay, it's just reflect there because it's the stateful part of Kubernetes. So a quick way of doing some checks. I mean, yes, check your disk and check your latency, but if you see that those are okay, look at the number of objects that you have in the database. And here's some hints. We have seen some interesting bugs on products or operators or people writing that start by accident. They start writing like every second hundreds of secrets or config maps. Guess what? That will get serialized. So imagine if you have something automatic creating those forever, you will see the etcd dying, but it's not because of the etcd. Etcd cannot handle anymore because you are sending the world. So sometimes just keeping an eye on the numbers of object types that are being created per second, it gives you a clue on, hey, who is the one killing this? Mm-hmm. And yes, you can play with the API, the fairness as QoS basically. But yeah, it will still get to etcd. So keep an eye on those, which is normally not something we do. And they will tell you a lot on where to look for the issues.
Secrets and events, especially events. Events have a special place in my heart. I won't say if it's good or bad, but they have a time to live. And the only way, if you leader elect, the only way that you can ensure that the time to live has been passed is to reset it. So if you have a time to live, I don't remember what a secret is, or an event is, but let's say it's an hour. If it has a time to live of an hour and you've waited 59 minutes and you leader elect, you have to reset that timer. And so things stay around. And if there's, so there, if you notice that you, with the link that, that we just posted, if you notice that there are a lot of events, and I'm talking like hundreds of thousands, you might want to go in and cull those. That might be a happy place to start, because spoiler alert, we've gotten a couple of issues with that before.
Well, and that's good to know, right? Because I think a lot of times when we get to that point, we're in thermonuclear mode. We're like, all right, it's time to take this thing down, you know? So it's good to be able to go in and check something and, like you said, cull them back, and maybe it actually fixes it. So
yeah, so you know, I said when it leader elects. So ultimately, it comes back to if we can, you know, identify pressure points, or you know, add some tolerance with the levers, then you know, we can maybe avoid doing some leader elections, and we don't have to go in and nuke all of the events out. But those are some things to look for.
Reminds me of, you know, the old Windows administrator habit of periodically reloading the server just because the registry gets crufty. So Peter asks, are there any alerts or insights rules that call out underpowered etcd nodes? Not just disk latency, but too few cores or memory.
OpenShift monitoring does have a couple of them that are built in as part of OpenShift. Let me see. I think it was one of them is like if it reached above 60% on the memory utilization on the control plane. I do not recall the details of the other ones, but yes, we do have in addition to the dashboard that we have, we do have a very important set of alerts trigger based on, let's say we have been there, we know when you should start looking at things.
Collective wisdom,
exactly. That's a way of putting it. Yes.
And our Hope 9 points out that, you know, they're in the form of Prometheus alerts. I think it's also two-step. Like Prometheus will tell you that there's an error, but I think the etcd logs themselves are pretty good about pointing out like, hey, this node missed a heartbeat because of CPU pressure. That type of stuff.
Yeah, but I mean, I don't know many people looking at the etcd logs daily, you know.
I mean, that's how I go to sleep at night.
Yeah. We might not be the best sample size.
I just print them out, and you know, it's my bedtime.
That's what I watch during my workouts. I get amped up, you know.
Manikatan, I'm not sure what you're asking there. etcd/API high request count. Maybe that's just one of the counters or one of the things that you're referring to.
Yeah, we do have those.
No, thank you. Potential spam call. I will decline you.
Yeah, and there is an alert for a high number of leader elections, which I think is 5 in a couple of minutes. So that's a good metric to keep an eye on as well.
I mean, I think most of us would feel like 1 in any period of time is probably not a good thing. But all right, well, this has been just phenomenally informational for me. You know, as we said before, I've learned some kind of basic things that apparently I've been misunderstanding for a very long time, and that always makes it a great stream, in my opinion. So, thank you both for coming on. This has been just amazing, and I've thoroughly enjoyed it. I think the audience has well. I see a lot of compliments in the chat here, so. I'll reiterate one more time for anybody who's not watching us live, please don't hesitate to reach out, or anybody who has been watching us live, if something pops into your head afterwards, please don't hesitate to reach out. Sully at redhat.com, SULLY, or Jonny at redhat.com, JONNY. With that, while I figure out which buttons I'm clicking, Jonny, I'll hand it over to you to kind of walk us out.
Okay. No, guys, I really do appreciate you guys coming on. This was awesome. Like I've learned a ton today, and I could keep you here for another few hours and just keep asking questions and listening to you guys like nerd out and stuff like that. So really, really thankful for your time and appreciate it. We'd love to have you come back, honestly. Like if y'all want to come back, you're more than welcome to come back whenever you want. So just just let us know. And to the
Well, we
audience,
have-
thank you.
Talk the
Maybe-
operator.
Maybe when
Yes.
the profile or the profile thing goes GA,
Yes.
Yeah. Or the AP, or the backup API.
or that.
Yeah.
Why not
Yeah.
both?
Yeah.
Why not vote? No, let's do it. I really do. I think it's awesome. And to the audience, thank you for all the questions, because like you're why we're here, and like to have you guys interacting like this, and it just makes it go that much better. So thank you very much. And that's it, Andrew.
All right. William Allen, any last words?
Oh, thank you, and see some of you on OpenShift Commons next week. We'll be around. So
Yeah. Well, actually, that's a good question. Will either of you be at KubeCon?
I'll be in OpenShift Commons and KubeCons. Yes.
Okay. Well,
Yeah, awesome.
there you go. I would say don't stalk William, but go visit William and ask him hard questions.
Yes.
All right, Joe. We will see you in 2 weeks here on the live stream. I better put my fingers down before macOS gets crazy on me. We'll see you in 2 weeks here on the live stream. Enjoy the KubeCon content next week. I know that there's a lot of stuff that's streaming there, including Commons. So be sure to visit, is it openshift.org, I think, for all of the links there. And have a great rest of your week, everyone.
Thanks.